Hello, today we are going to present about applied energy. It belongs to MG Fit Group. There are Mr. ก้องภพ ชิวคลี่ Mr. ประกิต สันตจิต and Mr. สรสิทธิ์ รักวงศ์ We are the member of this group. Introduction. The adoption of residential solar photovoltaic system or PV is highly dependent on expected private benefits. Mosely et al. Find that the main concern for potential PV adopters is whether PV provided enough bang for the buck. Typically, a solar adopter expects a lower monthly electricity bill after PV installation relative to a comparable season's monthly electricity bill before PV. The regional electric rate and structure, as well as net metering policy, play a crucial role in affecting electricity bill savings attributable to residential PV. Based on such inputs, an optimal PV site is determined based on which expected saving in the electricity bill is calculated. The contribution of this study is to understand actual electricity bill savings attributable to PV by using a customer's pre- and post-PV bills and provide a comprehensive comparison between actual and estimated monthly electricity bill savings for a sample of solar adapters in the United States. Insights gained from this study can be used to improve model inputs and assumptions. Furthermore, an understanding of the gap between predicted saving and actual savings facilitates informed decision making. Data from residential solar adapters. This study used survey data collected from residential solar adapters in 4 U.S. states: New York, New Jersey, Arizona, and California. The survey was conducted by the National Renewable Energy Laboratory or NREL under the project entitled Understanding the Evolution of Customer Motivations and Adoption Barriers in Residential Photovoltaic Markets. The survey was collected between December 2014 and April 2015 from single-family and owner-occupied households. Almost all solar adopters that lowering their electricity bill was a very important factor for their decision to adopt PV. As Table 1 indicates, for the sample considered in this study, post-PV bills are on average lower than pre-PV bills. And this is Table 1. You can pause the video and read it yourself. Thank you.
Methods. We use equation y equal x beta plus epsilon to calculate. Y means electricity bill each month. X means directions of variance resulting from savings. Beta means electricity bill and epsilon means error value. Results. This is the example of the results. The right diagram shows the money that New Jersey, New York, California, and Arizona can save in estimated savings and actual savings in average summer and winter. The left diagram shows estimated savings and actual savings by year of PV installation. Thank you.
The dependent variables are a log transformation of actual and estimate savings. Delegation includes correlates measuring PV load ratio, PV performance, PV ownership, electricity consumption, and state dummy variables. The correlation of the residue in the estimate and actual equation is 0.2042. The Bruce-Parkin test of independence. The R square for the actual servings location is 0.58 and R square for the estimate serving location is 0.53, indicating the model explains over half of the variation in independent variables. That model which estimates savings slightly better than actual savings, although the R square is not high. In order to make more accurate and generalized prediction statistically significant coefficients can still be considered as a real correlation between correlate and the response variables. The mean and median residue from the two dependence variables are both positive but very low. The low value of residue mean standard error indicates the average accuracy of the model. Hence, the data points aligns with the model very well. Technical factors such as the PV load ratio, the Hall characteristic can easily be observed and incorporated into estimation models. However, it may be more difficult to predict the actual electricity bill of solar adapter based only on their initial electricity usage and expect PV generation.
Conclusion.
Thank you.
This study provides a retrospective analysis of whether expected savings in electricity bills are actually realized by a sample of solar adapters in the United States. The study finds a systematic difference between estimated and actual electricity bill savings based on the given sample. This study finds that on average, estimated savings are lower than true savings. This study finds that the determinants of estimated savings are more technical and different from factors that affect actual savings. Other larger houses with purchased PV and fewer panels per floor area have a higher estimated savings, whereas newer, smaller houses with less PV and several panels per floor area have a lower estimated savings. Thank you.